afternoon, everyone. Thanks for the introduction. My name is Dennis Kangoka from Synopsys, and I'd like to take a few minutes of your time to talk about this topic, looking at the future of AUTOSAR, potential new collaboration opportunities, especially focusing on software and cybersecurity. So my background is in automotive security. At Synopsys, I work on mostly secure software development lifecycle, securing supply chain. So using my background experience, I'd like to share some of my thoughts of where AUTOSAR can go with potential partnerships in the future. Right, so starting with the agenda, actually before I start with the agenda, I actually plan to include a joke to start the session. So I asked ChatGPT to write me a joke, including the word AUTOSAR, so it would be relevant. But maybe ChatGPT has a different definition of joke, because what came back was terrible, so I decided not to include it. But if you're interested, feel free to catch me outside and I'll tell you the joke. So with that, we'll go straight to the presentation instead. So 3 topics today. First, I'll just share a little bit of the intro to automotive cybersecurity. Some of you may know this already, but we'll talk a little bit about trends and new threats and different types of security considerations. Second, we'll talk about some of the activities that AUTOSAR has already been doing in cybersecurity. So there is work since many years back where AUTOSAR has worked on different security specifications, templates, and so on. So we'll just briefly go through some of those to show that there is work already done in this area. And then I'll move on to the third phase of the presentation, where we'll talk a little bit more about what else we need to think about with AUTOSAR, which directions could we go, and what are the new things, so new areas that would be interesting for AUTOSAR to look into. So let's start with just a very brief overview of some of the trends. This is a few years old now. People were talking about the case many years ago. I'll just briefly go through it. But I'll look at it from more of an attacker point of view. So we'll start with the C, connectivity. We have different wireless interfaces. We have your Wi-Fi, Bluetooth, V2X, and so on. And from an attacker's point of view, that means there are new attack surfaces, new ways for you to target a vehicle, remote access to vehicle. So just looking at all these new features we can build in, we also have to think about it leads to new opportunities for attackers to target those interfaces. Second, autonomous functionality. Here we have control of your steering, braking, acceleration, and so on. Again, you can imagine these are new assets we have to protect. If attackers can manipulate these functions, they can control the vehicle, cause damage to the vehicle, cause safety damage, injuries to driver passengers. Also different sensors, we have new inputs, cameras, radars, lidars, and so on. All of these are, again, new attack vectors. An attacker can jam signals, they can spoof signals, they can send whatever they want over these interfaces to interrupt the system. The S, sharing services. Again, here we talk about new functionality coming in beyond the vehicle itself. And again, as an attacker, it might be easier to target those type of mobile applications or cloud services, web apps, rather than target the vehicle directly. So if I exploit a weakness in a web app or an API, I can then manipulate vehicles. I can unlock the door. I can read out certain data. So again, looking at assets, what do we need to protect? Again, we have a lot of private information here as well. So it could be users, addresses, phone numbers, financial information, credit cards, and so on. And then we have the E, electrification. So again, here we're looking at potential new interfaces. We have the charging ports, we have the charging stations. And as an attacker, we can target the charging port, get access to the vehicle. We can also target the charging station. And, for example, install some malware. For every vehicle that goes there and charges, they'll get affected by the charging station. So looking at all these new types of threats, attacks you can do, that are being introduced by these different trends. And moving on to the scope as well. So we have not only a single vehicle, but we have the whole infrastructure, the whole ecosystem. We have smart cities, we have IoT devices. So now again, as an attacker, I might not be able to target the vehicle directly, but I can target a weak or vulnerable IoT device. I can target a vulnerable service in a smart city that will then infect the vehicle, for example, and then spread again. So now I can attack millions and millions of vehicles. We also have software, so software-defined vehicles, more software being used, again, software for critical functionality in the vehicle. We talked about the steering, acceleration, braking, and so on. We also have more open source software, OSS. This was also mentioned by a previous speaker. So we have more software that is developed outside of our control. And if we use open source software, there are risks with that. Compliance risks, but also license compliance risks, but also vulnerabilities that may be introduced by an open source component. And of course, the OT updates. This is, again, another way for an attacker to exploit this update channel and potentially install malware or malicious software into your vehicle by abusing this update channel. So just looking at some data on reported cybersecurity issues or attacks from the past few years. I won't go through this in detail, but just highlight the top three. Number one is keyless. I think many of you have read this in the news already. QC attacks, targeting keyless, entry systems, relay attacks, replay attacks, jamming attacks, capturing signals. We have cyber attacks, which is a very broad category, but generally any software vulnerability that you can exploit will fall under the cyber attacks. And then we have the EV and charging as the third largest category. And again, as I mentioned before, we have this whole new infrastructure, charging stations out there. You have new protocols being used, and again, attackers targeting this. Thinking of the use cases, for example, financial damage. I can charge my vehicle for free if I can exploit that system. So looking at the summary of some of these challenges we see in the automotive industry, as we shift to focus more towards software, I'll just briefly go through some of these points. We talked about more software in general, faster development. We see faster release cycles. We have to add new features and enable those updates to users much faster. New technologies, we talked a little bit about this with connectivity, autonomous cloud, web apps, and so on. Some of these technologies may be new to traditional automotive organizations that have a long history in embedded development. Now suddenly you also have to do your cloud development. You need to have that expertise, you have to hire people, train people, or maybe partner with other companies. Software risks, this is again very common, I think everyone knows, but again, quality, safety, security. We have to consider from an attacker's point of view, what can happen if we have these new features, this new connectivity, these new use cases. And then last, also supply chain. So everything is not built by one company. We work with suppliers. We get software from the suppliers. We have to consider how secure is that software, how much testing has been done. Do we do the testing? Does the supplier do the testing? Who does what? Also, if we start using open source software, how much has that been tested? Can I include that in my safety critical components and other types of systems? How do I still make sure I have proper security assurance? And then very briefly, looking at how some of the changes in the industry is occurring. So on the left-hand side, we have the more traditional ECU software development, V model. As we shift more towards right, we see move towards so from microcontrollers to HPC, high-performance computing, more towards mobile services and cloud computing. And we see also on the spectrum at the bottom, so on the left-hand side, we had more focus on safety, for example. As we shift across the right side, we go more towards security. Left side, we have, again, pre-release testing, typically as part of the V model, the validation at the end. As we move towards right, faster release cycles, we shift to continuous integration, continuous testing, to DevSecOps. Again, left side, traditionally using C, C++. Again, we shift towards the right-hand side. We see other languages coming in, Java, Kotlin, Flutter, Rust, and so on. And again, typically on the left-hand side, no OSS being used in these systems. But again, moving on to the right-hand side, you see more open source software frameworks, libraries being used. So we have to think about how do you incorporate this with the security threats and security solutions that we can incorporate. So as one approach here, as I briefly mentioned on the previous slide, was DevSecOps. So many of you may be familiar with this already, but just to briefly mention some highlights. So we have this loop here where we continuously code, build, test, release, and then go around in a rapid fashion so that we can capture feedback early on. So this helps us maintain development speed. We don't have to go through the whole long V model to update requirements and make changes. So we can reduce costs by finding, fixing issues earlier on. We can implement changes, new requirements quicker. We can automate more using tools, so especially in our CI pipeline, including various test tools, security testing tools, static analysis tools, dynamic, and so on. And then we have the continuous feedback. So running these more in an automated fashion allows us to get that feedback, fix issues, and then release software with higher quality. So that was a brief introduction to automotive security. We'll move on to a very short summary of AUTOSAR and cybersecurity. So many of you may be more experts on this. They may have been involved directly in developing some of these different specifications and standards and so on. But very briefly, starting from the left side, we have the AUTOSAR C++ coding guidelines. These are used by organizations to develop safe and secure software. So following these guidelines help you reduce the introduction of certain types of weaknesses and vulnerabilities. We had the SHE specification that originally came out in 2009 by HIS, but then re-released by AUTOSAR, again highlighting the need for secure hardware in our ECUs. We have secure onboard communication, SecOC. Again, having a specification that describes how they do or send secure messages over CAN or Ethernet using a MAC, message authentication code. CSM, our crypto services manager, again helping with anything crypto related, with encryption, decryption, hashes, signature generation verification, and so on. And then we also have the IDS, which is injection system, and the manager there. So being able to detect attacks on the vehicle. So we see that progression from the size, the typical software architecture AUTOSAR has, this focus on security solutions and approaches as well. And then on the right-hand side, just to highlight some of these additional security approaches, suggestions found in different AUTOSAR documents. So there are suggestions on using secure coding. You have different techniques here. You can use different compiler flags, or you can use solutions based on the hardware. So you can set your DP, your data execution prevention flag, use ASLR. You can have CFI, control point integrity, CPI, control point integrity, and isolation virtualization. So using virtual memory to separate processes, or have your virtual machines. So just having different ways of reducing the privileges so that if there's an attack or vulnerability, it doesn't spread over to other applications. And then just to highlight one example of a partnership, I think this was announced last year. So our AUTOSAR and Global Platform announced this partnership. Those of you who may be familiar with Global Platform has been doing work in different standards for different industries, focusing on secure hardware, secure components, secure elements, T, trust execution environments, and so on. So they're also now working with AUTOSAR to bring that focus on automotive. They have established this cybersecurity vehicle forum They also established an automotive task force that's working on these topics. And here's one example of an initiative where they want to develop a secure API to allow AUTOSAR-based systems access to global platform protected assets, such as your secure elements or your trust execution environment. So having all these standardized activities going on is a very good direction that AUTOSAR is moving into. And with that in mind, in the next few minutes, I'd like to share some of my thoughts on additional directions that AUTOSAR can take. So these are more of a thought process from my side, so just jotting down from my brainstorm areas that I think would be interesting. It doesn't mean that AUTOSAR hasn't already done work in these areas. There might be already some existing work, but this is just to highlight where we can go further and see how we can expand the reach of AUTOSAR. So, first example here is on secure software. So if I start again on the left-hand side, the objective is looking at secure software development. You have your supply chain. You need to make sure that the software is secure over the lifetime of the vehicle. So the activity here, as an example on the right-hand side, is for AUTOSAR to work with different industry leaders in the AppSec, application security domain, work with different industry associations, and look at some of the best practices for secure software development lifecycle, secure SDLC, as well as software supply chain risk management, CRM. So again, you can look at, there is existing work in other industries, how can we reuse that or apply it to have an AUTOSAR specification or standard that looks at this. One example is with the SBOM, software bill of materials. So when you create your AUTOSAR software, different AUTOSAR vendors have different ways of creating SBOMs, different formats, different naming conventions, different hierarchies. So establishing some form of specification or standard or guidance that allows an organization to have the same type of information from multiple different AUTOSAR vendors, so that you can easily use that and integrate that into your entire software system. Open source software, so we talked about this a little bit. There's also been, I've seen some, I think there's an open source implementation of the DLT, the diagnostic log and trace, as one example. So we might see more components, AUTOSAR components, being released as open source software. How do we manage that? How do we have guidance on license compliance if you release AUTOSAR software as open source? And again, this goes together with the SBOM as well. So how do you release a proper SBOM that can identify those software components, track them? You can look at collaborations with, for example, OpenChain, which has done a lot of work on SBOM and OSS. And then vulnerabilities, vulnerability management here being a very important topic. If there's a vulnerability found in an AUTOSAR component, how is that reported? Is there a vulnerability database that's shared? Is there a specific format to report that in? Again, so that if I have multiple vendors, I don't want to receive a report in one format from one AUTOSAR vendor and have access to another database for another one, or maybe VEX, the vulnerability exchange information from another one. So coming to some kind of best practice of how do we share vulnerability information. The next topic here is on the cloud. So as I briefly mentioned in the beginning, we see again this integration with services operating in the cloud. So cloud, we have data being collected, data being processed, different use cases, data analytics, management, fleet management, and so on. Here the activity could be that AUTOSAR could partner with cloud service providers, such as AWS, Google Cloud, or Microsoft Azure, and work out some standard approaches for how we manage AUTOSAR software interactions with the cloud, come up with the scalable solutions and secure integration practices. And moving on, smart cities and IoT. So we had this example in the beginning. Now, if your vehicle is interacting with all these different entities and services in a smart city or with IoT devices, we also have to look at, is there a way for AUTOSAR to engage with these IoT alliances and smart city initiatives and come up with some kind of specification of best practice for the safe and secure operation of vehicles and services within that environment. So again, going beyond the vehicle itself to having the APIs or the communication defined by AUTOSAR. The next one here is V2X. So V2X, we've seen already a lot of work being done, both for like V2B, V2I, V2P, and so on. And one example here is to engage with 5G AEA, for example, the 5G Automotive Association, look at the use cases that they have, see how can AUTOSAR fulfill those use cases, what kind of security protocols or security solutions are needed. So I'm looking at it beyond the traditional normal communication integration, but more from a security point of view. And I know there's some work already by AUTOSAR. I think there's some V2X message specification or so. But going beyond and looking at the overall ecosystem, how do you do the authentication, key management, and so on, and working together with SC and IEEE, for example, to come up with common standards and specifications. And then finally, looking at the EVs and the charging stations. Again, we saw this with new threats coming up, targeting these systems, those top 3 reported issues in this area. So, sorry. Yeah, that's right. So, here again, we see communication between EVs, charging stations. I think, again, AUTOSAR does have some specifications here. I think there's a charging manager specification. But going beyond this, again, looking at the security aspects, working with alliances like OCA, Open Charge Alliance, and other industry leaders in EV to come to some consensus on common protocols, charging security before the charging station and the vehicles. It can be built on ISO 15118 and so on. But looking at, again, how can AUTOSAR support these use cases and, especially from a security point of view, reduce the risk for these use cases. So that brings me to the last slide, and try to map back what I talked about to the agenda. So again, just to highlight and recap what I talked about, we started with some cybersecurity in the automotive industry. We talked about some of the new threats and attacks. Again, looking at PACE and STDs, for example, we have all this new connectivity, we have more assets we have to protect, we have to look at the software that's being used, open source software. So I urge you to, whenever you look at these use cases, to look at it from an attacker's point of view. What are the assets we have to protect? What are the ways someone can attack that system? And then look at the solutions we can apply. Second, we did cover some of the examples on AUTOSAR cybersecurity-related activities. I won't review them here again, but there is already work in this area. And the last part is moving forward, additional areas where AUTOSAR can look into regarding software and cybersecurity. So we talked about the secure software development, establishing that life cycle, having best practices guidance on how do you do the development, how do you do testing, looking at the secure software supply chain. How do you verify software you receive from suppliers? What's the process? What kind of testing should be done? Providing best practices and guidance. Talk about cloud integration, again, working with cloud services providers to understand how we have good secure protocols, authentication protocols, and so on. IoT smart cities, again, similar, looking at partnering with those type of alliances. V2X and EVs, again, looking at going beyond the vehicle, looking at what are we connecting to, what kind of security protocols, solutions we need, best practices, specifications. So that's the end of my presentation. I'll be around, so if anyone has any questions, I'm happy to take them.